Probably a really good example that we see and happens to us on a regular basis relating to the rate of diffusion and evaporation is coffee rings. Now, coffee rings form when we drip some coffee onto the floor or a table or something like that. What we're going to have a look at is what creates and generates the rings around the outside of these droplets of coffee. So it's just a bit of fun, but we'll have a look at that because it is sort of related to the rate of diffusion and evaporation. So that's the whole idea of this short little video that we're going to cover over the next 2 or 3 short videos actually. So we'll explore coffee rings. Okay, so I'm outside and I've just made myself a cup of coffee, and what I'm going to do is I'm going to carefully spittle some coffee onto the plate, and we'll put 2 or 3 drops around. And what we'll do is we'll come back later on and we'll have a look at these drops, and we should see that they've evaporated and left some rings around the outside. Anyway, we'll see what happens later on. Well, this is about 4 hours later, and we can see we've got a distinct series of rings around the plate. Unfortunately, I moved the plate and we ended up getting some double rings there, but it doesn't matter, we get the general idea. And we'll see the time lapse later on. It's going to be a little bit more defined. Okay, so we're looking at our coffee, looking at from the side on view on our table or our floor or wherever might have spilt it. And the reason why it's quite a raised shape is the fact that wood has got the second highest surface tension of fluids, second to mercury. So it actually has that raised look when you're actually looking at it from the side. But we know that the rate of diffusion also leads into the rate of evaporation, and that's what we're concerned about. Now, or we're interested in. What we know is the fact that the rate of evaporation is going to occur not at its highest point here, but it's going to occur at the point where the water is going to be at its highest temperature. And that is going to be right at the very edges. So the greatest degree of evaporation is going to happen out here. So if the greatest rate of evaporation is going to be occurring there, then the fluid that is moving away and being evaporated from those points is going to eventually need to be replaced. So in doing so, the size of the bubble gets lower and lower and lower as that bubble starts to evaporate. So that fluid is continuously being replaced out on the edges. If we do another top view, all of that coffee is making its way out through to the edges, all the way around, and in doing so is going to leave that distinctive ring around the outside. And that's what we're trying to show. So we're eventually going to end up with quite a large ring because the fluid that is been evaporating out from those edges is continuously replaced by the much larger volume of fluid passing down through to replace it. And that's why we end up with our coffee rings. And the next video we're going to do is just show you a time-lapse photograph that I've taken of coffee rings on a plate there that I put on there a couple of weeks ago. Okay, so like we were just saying, this is a video that I did, or time-lapse that I did a few weeks ago, but it worked out very well. So what I've done is actually just taken, overlaying this voiceover, including the chooks, over the time-lapse. So it's another example of the rate of diffusion and how coffee rings can form over a period of time. So I hope you got something out of it. It's a little bit of fun, but just another example as to where the rate of diffusion occurs on a regular basis.